Hey everybody, this is Larry. This is me going Q4 of the weekly contest 514 Peaks in Array 2. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. So this one I was very sad about. I should have been able to do this during the contest, but I ended up taking about like 2.5 hours or something like this. And honestly, this one is easier it's easier than 2.5 hours. I should have gotten it earlier. I just went into a lot of confusion because there's no way around it. There are two things. One, or there are at least two things. Say right. One is that I misread the problem. For this particular problem, and I'm explaining my thought process before I explain the solution. I mean, listen, you could figure out a solution in many ways. There are a lot of places you can get it from. But I want to go for my thought process and things to learn from, right? And for me, I just kind of, first of all, it's just that I misread it a bit. Because for this thing, there's this thing called peak subarray, where you have this subarray that contains a peak. But for some reason, I read this as like a mountain subarray, meaning that this is a valid subarray if, like, you know, it goes up and down like this. But I just misunderstood it. So then I was trying to construct stuff with like the left segment and the right segment and how far it can go and stuff like that. It was a mess, and I spent way too long on it. That said, way too long on that part was like 30 minutes, and not like there was still another 2 hours, right? So that is a reason, but it's not the only reason. The second reason, and you know, this is something that I have to figure out how to do myself, right? Is that well, let's say there are more reasons, but the second reason is because let's just to be clear, I knew exactly what I had to do for this one algorithmically. Like, I don't know, maybe say 5 minutes in, because you could even say that for the others. Even though I misread it, the solution would have been the same, in theory. Implementation is really different, and there are a lot of logistics and bookkeeping and stuff like this. But in theory, the idea is the same, which is a data structure problem, a bookkeeping problem, stuff like this, right? I had the idea pretty quickly, but the truth is, I was tired, and that is an excuse. But you know, sometimes, and maybe this is what happens during an interview as well, right? Is that, look, if you don't sleep enough during an interview, if you're tired during an interview, your brain just don't function the way that you would like it to. And for me, it's not even that necessarily. It's that I just had a bad attitude about this problem. If you watch the live portion, I was complaining the entire time. I have some excuse. I was tired. This is my first week of tough marathon training, so I ran like 45 miles. And I'm just like really tired, and when you're tired, you just don't want to do anything. I don't know. Look, these are excuses. Maybe they're valid, but at the end of the day, if I was tired, I just should not have done this contest, right? Until I'm less tired. So at the end of the day, still. But why I bring it up is because, you know, like, if you want to succeed, you have to put yourself in a position to succeed. And I did not do this and I did not respect the problem. I was lazy. I just didn't do it, right? I mean, I still kind of like tried to grind it out, and I did grind it out slowly and eventually, but like I said, I kind of just confused myself, and I just like overcomplicated things a few times and stuff like this. And then the third thing is maybe as a result of that, because as I said, I knew the shape of the problem, I knew the texture of the problem, you can say. I know how the problem feels, because I've done variations of this many times, right? So I knew what I needed to do, but as a result, I was not rigorous. I was not tight. And what I mean by that was that I dealt with a lot of off by ones where I was just trying so hard to figure out what I was doing. You cannot debug and off by one if you don't have a clear understanding of your thing. I mean, maybe you can by just getting lucky, but what I mean is that well, if you have days where you're not lucky, like I am today, then you have to rely on something a little bit better. And I was a little bit confused about how I store things with respect to off by one, inclusive, exclusive, what is the actual query means, and as a result, I just was not able to do it for a long time until you could say it's a breakthrough at some point. Maybe I had a breakthrough at some point, but you could also say that maybe it was just long overdue and I would have ran into it eventually, and I should have seen it earlier, and I would have agreed. So yeah, okay. So that's all the context. I know that this is kind of wild that we're 6 minutes into the explaining part, and I haven't even started explaining it. But yeah, so okay. So let's step back now and actually explain the problem. I just want to kind of point these things out because I know that I don't know if I'm setting out to be a role model, but these things, it happens to me even, right, as you could see, and I don't consider this one too tricky algorithmically. Implementation wise, it's one of those problems where it's probably mostly implementation, but as a result, you have to be careful, right? And you have to practice to write it in a clean way. Otherwise, you'll be stumbling along like me because I just didn't have a clear understanding. I mean, I'll give you another example, which like from this problem, so it's not like unrelated. Is that spoiler alert? This problem needs a little bit of a segment tree or something like a segment tree, and it took me 10 minutes to realize, and I was debugging it, that this is I guess what happens when you're tired or not, whatever, I don't know. But for this particular problem, you need a addition segment tree or sum segment tree, summation segment tree. But my template is usually in max because it's easier. I find it easier to convert it from max to sum than the other way around. So my template's in max, and it took me 10 minutes to realize that I was using max, and I was so confused and not using the summation one. So it's just one of those days. Sometimes you also just have bad days where everything kind of all those things kind of come against you, right? But that's why you practice, right? Because when you practice, so that your bad days are still better than other people's good days, hopefully, right? In any case, okay, let's actually get started on the problem now. So what is a peak subarray? And this is the part that I did not understand because I misread it. But a peak subarray just means any array that has a peak. So for example, if you have 1, 2, 5, 5, 2, 1, there's no peak here, right? Because the 5 is not a peak, and this other 5 is also not a peak. But in a weird way, at least weird to me until I realized I misread it, this array has a peak subarray. This array is a peak array or peak subarray. Even this is a peak subarray because this contains the peak, which is the number 3 here, right? This is our peak, and this is a subarray without the peak, right? Or with the peak. Okay. So once I actually read this correctly, it actually was very quick for me to realize that, okay, in that case, because, okay, there are two things, right? One is that if this is a static problem, meaning we don't have updates, then this is actually, and you should practice that part. If you haven't done it yet, practice that part, because it is actually a good practice, a good problem, and I think maybe it would even be a hard, or maybe a hard medium. So it's not a give me, but yeah. And a spoiler alert: if you're trying it, pause and come back. But if you're not, spoiler alert: that one is a sliding window problem, or what I call a contribution problem or a solution, I suppose, where But the idea is that, yeah. So in that case, then you can play around with whatever, right? But in this case, for me, if you're given a range, right? Let's just say a range looks like this, right? Then now, for me, it is actually easier, instead of counting the number of ranges with the subarray, how many subarrays containing a peak, it's easier to count the number of subarrays that do not contain a peak, it turns out, right? Because basically, let's just take the whole array first, right? If you take the whole array, for example, then this contains, say, n numbers, say n numbers, we know that we have n choose 2. No, it's not n choose 2 because there is replacement, right? So yeah, n times n plus 1 over 2, right? Number of ways to choose any subarray in general, and then the number of so you want to remove the subarrays that don't contain anything, and those exist just by, you can think about them as a segment, right? Because for example, then now it is just this segment. This ASCII hard is kind of hard. You have this segment of one number and this segment of two numbers, right? 1 and 2. And then now from this by itself, you can construct everything, right? In any given range, right? Because the idea being that if this is a segment, I call it a segment of five numbers, then that means that there are 5. You use the same formula, but for number 5. Number of ways where it does not contain a peak, right? And I think this is the part, and there are a couple of ways you can store this, of course. For me, I just store it on here, right? So, for example, we have 5 numbers. So 5 numbers, what was that? 15, right? So that's 15. So I store 15 on the 1. And here on the 1, we should store 1, right? Because that's just only 1. And the 2 numbers, we store 3 on the 1 and 2. And then now if you do a query, and the reason why this comes up is that when you do a query, then now you can get the sum of everything inside in the segment tree very easily, right? I mean, that's just basic segment tree stuff. At least if you use the right segment tree, and like I did. This is of course also a point update segment tree and a range query segment tree. Right, pretty straightforward because these matches what we want to do. We only update one point at a time, and we only update one at a time, and we only get range query over a range, right? That's the point, the sum over the range. Anyway, yeah. So that's kind of mostly the idea. That was enough for me to get like I was like, okay, because then now you can think of just the other possibilities. For example, if the left side and the right side are inside the same range, you have to do some funky stuff. If one of them, and of course, if one of them is extending past that, then you have to do some math on the right side and the left side. And that's it. I mean, I am going to go into more details, but I just want to give you the structure of the thing, right? And of course, then now, when you update something, there are a couple of things that can happen. And actually, I got this part right, as partial credit, I suppose. No, but if you let's say you say update this 5 to an 8, then now this is a peak, and now that this is a peak, then now we basically just divide up a segment. So that's pretty straightforward, right? And of course, for the segment, now we update it to only contain 2 numbers, which has 3 possibilities. There's only also 3 possibilities containing 2 and 1, right? And then now you have peak. And of course, that's just an example, right? Because you can also change this number, but another number becomes a peak, right? For example, if this changes into 3, then actually the 5 becomes a peak. But the same logic applies, just 1 over, right? Because now it might be not a peak to a peak. And stuff like that. And of course, you can obviously convert the other way as well, right? For example, if we change this 3 to 1, then now this is no longer peak. So then now you merge these things, right? And that's it. I mean, so those are the operations. And as long as you kind of And that's why I said by bookkeeping is that you keep track and make sure all the numbers in the segment tree are updated, and you store it and stuff like this, and you know everything is okay. Easier said than done. I mean, I'm saying it like it's, you know, I mean, I should have done it quicker, but it still took me a long time. So yeah, so that's basically the idea. I'm not going to go over the segment tree in this problem. So all you have to know about segment tree is to use it as a black box, which is that we have two things. As I said, you have a point update a value at an index, which we, for this problem, is going to be given a peak free segment. We store the number of subarrays on the left index, right? So your leftmost index thing, right? And then you have range query, right? Range query for a given well, the segment tree is just get the sum get the range sum from left to right, and for our contacts are just given left and right, get the total sum inside the the range, right? And that's it. Of course, there is some cases which we'll draw out, right? For example, you have a peak like 1, 2, 3, 4, 5, 3, 2, 1, right? And let's say, you know, your range is here from 2 to 4. Then now, if you do it naively, then this will return 0. But then you have to add back in these things, right? And then there's, of course, if you do something like this, and remember, you will store the segment. The segments are from 1 to 4 in this case, right? And that has what is it? 12? No, 10 maybe. Yeah. So this has 10 stored at here. This has 10 stored at here, right? But if you kind of just do this range query in a naive way, and this will get 10, which is fine. But then now what you have to do is break this into the segments, right? We know that we only have partial segments on here, so then this only has from 2 to 4, right? So here we subtract, well, we don't subtract anything because the 10 wasn't added anyway. So then we add back in the formula for 3. But actually, this is the part that I was very bad at and took a long time, is that for some reason I forgot that, I don't know why, I just forgot that the subarrays have to have at least 3 elements, which maybe makes sense, but as a result, when I was trying to add, so I subtract 10, right? But I don't subtract 10 on the left side. On the left side, the 10 is outside the range, so we never added it, so we don't have to subtract it. But here I took, and I almost did it again, which is that from 2 to 4, we have 3 numbers. So that means that we have, I don't know, 6 combinations, right? Which is not true, because you don't have to have at least 3 elements. So this is only 1 thing. And that's where I made a mistake. Because for a long time, I was just finagling with the numbers, and I got it wrong. Because I just got really confused. And then I realized that it is the same of because then now you cannot, because you can say that the left and the right bounds are fixed, so then it's just the same as squishing it in one, because you have no control over it, and you can just choose the one inside, right? And that's kind of the idea that I was a little bit confused about, and that extends actually, by the way. I mean, I was very confused about this, but for example, if you have from 1 to 4, even though this adds the 10, we actually, well, for this particular case, I think technically, Yeah, you're supposed to not add this 10 by subtracting 1 from the left. It's what we're supposed to do. And once we do that, then now we have this, right? And this extending, now we have 3 numbers, right, with 2 degrees of freedom, right? So that actually has 2, right? Yeah, because you can have 2, 3, 4, or 1, 2, 3. If we had, I think I'm writing this way. So you have this. So then that is, yeah, you can choose 1, 2, 3, 2, 3, 4, and 1, 2, 3, 4, right? So which is, but yeah, but you also don't include the 10 because the number that we are here would never be inside, right? Will never be inside. So when we do the math, that's the part that I was confused about. But yeah, right? Because it has to have at least 3 numbers. So now you have, yeah. So now you have 2 numbers, and then you do the math, right? Yeah, because because there are 2 interior numbers to yeah, 2 interior numbers to have choices about for the left and right side of things that you can that could be peaks, which is what you're trying to subtract out of here, right? Or it could be peaks, but also just subarrays, right? You could also just do the math another way. But yeah, and then on the right side, actually is the same idea of what we talked about, however confusing that might be, except that we also subtract out the 10 because we just included, so then we have to take it out. But we also compress it on the right side for that reason, is because whatever number that is, it'll never be inside. And that's kind of the idea. Again, we're not going to go over segment tree. I mean, I'm going to show you real quick, but yeah, and this is so long ago, I even used this thing for infinity instead of, my infinity that I usually write. But I don't know. This was written a long time ago. But yeah, it doesn't even make sense. I didn't even use this one, I don't think. But yeah, update. I mean, this is segment tree stuff, so I'm not going over it at all. No, do it at your own time, I suppose. But yeah, so I keep track of a lot of things so that we can just look things up easily, kind of, right? But with that, you have to be careful because now when you do an update, you have to change it in like many places. For me, I just kind of keep track of the peaks. I forget why I have this actually. I guess I use this for the initial pre-filtering. I don't store it. I have a peak set, which is just the set of peaks, so that we can see if a number is a peak easily. I don't know how I feel about that. I probably don't need this actually, but nonetheless. Oh, I know why I needed this. The reason why I needed this is because in a lot of problems, like something similar to this, you can just do like a before state is equal to, I don't know, some if statement, right? And in this one, you may say it's going to be like num sub I is less than, or num sub I minus 1 is num sub I is greater, it's a peak, right? And then then afterwards you update state, and then you check the after state is equal to this again, and then you can do some math or like some if statements depending on before state and after state and how they differ, right? But the problem with this one is that, as I said, at least for me, maybe there's still a clean way of doing it. I just couldn't figure out how to do it quickly, and my brain was mush and I couldn't figure out. But the thing that I was saying is that if you have something like this, the thing is that if you update this to this, well, the previous number could change, right? Like the number to the left can have a state change and not this number. So if you kind of update this, unless you do it like I don't know, there are ways to do it for sure, but you know, if you're not careful about it, then your before and after state might not be consistent. So that's why I wrote it. That's why I have a peak set to keep track of it. We'll show you in a little bit. We also have an array of peaks, but I just use this to keep track of stuff, as you'll see later. Test is just actually like for debugging. The test of I is mirroring segment tree is I've index, right? So this just contains what we said, where like the I've index is the beginning of a segment. It has all the sum of the subarrays that are not, what did they call in this one again? Not real, not peaks, peak array or whatever. Yeah. So then I just have this test so that I can print it out. That's it. Because it's hard to print out a segment tree. I mean, you could do it. I just don't have one ready. Anyway, then you have two functions that kind of do it this way, right? So here we have an add function, right? This is critical. You have add a new segment left, right. So then here we add to the sorted list, a list of all our segments that we can binary search for, right? And then count is just to count, right? This is the count function that we've been talking about. It's just counting the number of things. And then for the new count, we just update, right? Because that's what we said. On the left side, we update the thing. And also we update it on the test so that I can print out test. That's it. This is not necessary for whatever. That's why I call it test, right? And then remove is the same thing, but the other way, right? So remove an existing segment, right? So we have this. I don't know why I actually can move this out. Because you could just remove, anyway. Yeah, remove from sorted list, and that means updating the number of counts to 0, and it trusts that, you know, in other places it'll be done, right? And that's it. And then now, yeah, so these are like I said, all the segments are segments with no peaks. I call it peak-free segments, maybe somewhere. And then we have a segment tree. We start at 0, and then we just kind of start adding the thing, right? So if there are no peaks at all, then we just add a long segment from 0 to n-1. I think this, yeah, there are a number of ways it can happen, but you just add one long segment. Otherwise, then, you know, you draw from 0 to the first peak. Keep in mind that keeping in mind that if there exists a peak, the peak cannot be 0 because the 0 does not have a left side, so it would just never be the answer. And then next we do the zip thing, so then everything in between the peaks, you know, we add, and this is inclusive. And then we also add the last segment to the last endpoint. Keep in mind again that the last endpoint cannot be a peak, so this will always work. Yeah. So then now, let's go over the update first, because that's the part that I got pretty cleanly, which I'm happy about. Because I don't think I changed anything after the initial write. All my debugging was on the query. So anyway, so yeah, so if t is equal to 2 in this case, we have the index and the v. We update the nums. I don't know, I just always update stuff like this. Right? And then after updating, remember we have to track 3 possible state changes, which is the left, the current, and then the right? Yeah, so then index -1, index +2, but all the code is the same. We just do j. If j is inside the range, this is how we use the peak set. If it is, so the before peak, we just see if it's in the peak set. If it is before, then we just remove it. After peak, we set to false, and if it's now we just check the nums array that we already updated. If it's a peak afterwards, then it's a peak afterwards. And I have 2 state changes. Maybe this could be cleaner, but I don't know. After I wrote it out, I was just like, this isn't that bad. right? Yeah. So if it was a peak and it is not a peak afterwards, then we just is a peak removal. So we binary search, and this thing we want to, So the idea behind this is that we are deleting a peak. So that means that we are combining two adjacent peak-free segments, right? And that's basically what this does, where we have the left side, we have the right side, and this is what the binary search will get us. You could check it out. And this will always exist because I forget why. I do remember the reason. I don't know. Oh no, this doesn't always exist, but yeah. I mean, I even had an assertion here. I don't. Oh, because okay, yeah. Because if this is the I forgot. If this is a peak, then that means that there's going to be a segment after the peak, right? If this index is a peak, there's going to be a segment to the right that is that contains, right? So yeah, so that's why s of index will always exist, and we assert it here, right? And as long as the left exists, then we can just combine, and the left also I think always exists actually, because this cannot be 0, because 0 is going, like the 0 peak free segment is the one going from 0 to some number, and if we're bisecting or binary search on J, that would never be the case, right? Like you cannot go to the left of 0. But I just kind of have it anyway, right? So you take the left, you take the right, we remove it, and then we add a new one, merging it, right? Throwing in the gap. And then the other one is kind of the opposite, right? Is that if it was not a peak, then you have a peak now. So then now we were in a segment, or we were in a peak freeze segment. Now not right. Now we are in a peak. So I mean, this one's yeah, I mean, we just binary search, we find the segment that we're currently in, and then yeah, then we remove the original, and then you split it into thing, which does not include J. Yeah, that's mostly it. I think this is a little bit awkward though, but I don't remember if this could be like, I mean, this gets accepted, but I'm surprised now looking back that I don't have a guard against this. And I didn't really prove this where like this is less than or equal to J minus 1, because it can happen, right? That it is not before peak, and then now it is a peak on the edge of a segment free thing. Maybe this just clocks my thing up with zeros, and maybe that's why, which is not great, but maybe we should check that. Actually, yeah, let's add a check, right? So if original 0, I think that's a little bit cleaner. Unless it's wrong. If it's wrong, then it is not cleaner. Huh? Why is that? Actually, just want to double check that I didn't like. I don't know. Maybe I changed other things. How does this happen? What was the other wrong answer? Now I'm curious. It doesn't show me. Was my if statement wrong? Is that why? Okay. Ah. Sorry, friends. This is now turning into a live debugging session. These things happen. But 2-1. What are you doing adding 2-1 to this? It's okay. So you have this thing. I mean, it doesn't change the answer. It's just the assert is wrong. But because there's no actual like state check for this, which is kind of weird. But I think we get a wrong answer in the other one. So it's just that this one is not the one that catches it off. But why? Why? So 2, we changed this one from 1 to 10, so it was not a peak, and now it is a peak, right? Before, the peak 3 thing is going to be 0, 1, but then now it's going to be 2, 1. But why does this fail? Right, like the thing isn't that I mean, like why is this fair? That's the more interesting case. Like why this? Maybe I just got lucky. Even after that, I'm like now I'm confused why this works. But okay, so 1 we have 4, 5, 0, 1, 2, 3, 4, 5. So 4, 5 we have 0 of course. 2, 4, 8. So we change 0, 1, 2, 3, 4. We change this to an 8. So what used to be a peak is no longer a peak. But the 15 is a peak though. And so when we do 1, 5, so 1, 3, 4, 5, we change this to like how would this being this wrong fixes it? I don't get it. Alright, let's print out what do we call it? S list. Like how? How is this okay? How? How is so maybe so okay, so now I'm gonna say maybe my code isn't right and there's gonna be some challenges, but and you could probably, if you could figure it out, you could probably submit it to Leetcode for 100 coins or something, because this is accepted. But that's why I'm confused. But I mean, this is just implementation details, so feel free to fast forward if you're not interested in it. But how? It's okay. Let's also print out. This is why I have to test, so I can print it out like this. No, but that's not what I want though. I want nums that is updated. So let's print out nums like this. Because okay, so you have this thing. You have 2, 2, 0, 1, 2. Okay, that by itself is good. 3, 4. 0, 1, 2, 3, 4. 4, 5 is the right answer. I think I just got lucky in some way. Right? I mean, that's just going to give me 0, which is fine. But for that index. And then the 5 has it. But I think there is some... well, the TLDR is that my code is wrong. Just to be clear. Because what I have to do, it isn't that this is wrong necessarily. Well, I mean, it is. But what it means is that this should merge, that's all. But I don't... by the way that we did the binary search, and we don't assume, that's why it works. But I think that's just lucky. I don't think this is actually right at all. And even this part is not. Yeah, what? I mean, it's not right to remove it, but we need to. Yeah, maybe I didn't think about the states enough. Okay, so it went from. Wow. Wow. Yeah, looking at it, I was like, this doesn't look right. Now that I have a little fresh pairs of eyes. Or fresher, maybe it's not even that fresh. I'm old, man. Okay, so you have this at the beginning. Okay, let's double check. So 0, 0, 2, 3. Is 2, 3 right? Oh yeah. Because 16 is the peak. Whoops. 2, 3, and then now, wow. So I think I just got lucky. So now this is getting smaller. So then now this becomes a peak, and this becomes not a peak, right? So which step is this changing for? So okay, let's check. Okay, so 3. So 1, 2, 3. So okay, I mean that makes sense because it was not a peak and then became a peak. So then now 2, 2 is fine, though as we said, yeah. No, I think this is the better solution. But then now it's wrong, which is fine-ish. Which one am I looking at? I think this one. I didn't print out a new thing at the end. Okay. That's not right at all. What? So, okay. There's a lot of things wrong here. I don't know. I gotta accept it. Take the lessons and not good code, maybe. But am I looking at the right one? Don't really have to. I don't know about the energy to really debug this in detail. Okay, so that's the initial sorted list. I think that's fine. And then this is the end sorting list, which is not so fine. What happens is that for I think the order of operation here is why. I was hoping that it maybe readjusts itself, but maybe not, right? Because now, because we removed the 3, and that's right, but then we added the 4, and then adding the 4, we assumed that we just merged the 2 adjacent ones, like we said, but that's not apparently right, right? Okay, we could just fix that though. Where's the code on add? Okay, so we could fix that on add. Yeah, so here we there are a lot of cases though. Man, this code is just so wrong. We know that right always exists, because this used to be a peak, as we said. Okay, but the left also exists, but apparently because of the state change, because I assume that, yeah, maybe if we change the order, this is better. I don't know. So index -1, index +1. Does that change things? I don't know. Yeah, maybe it does. Because that's the way that I was thinking about it. Oh, I was looking at the input, but luckily also right. That's the way that I was thinking about it. But because going to left to right maybe implement something weird. I don't know. I don't know if this is good enough, to be honest. Still, I would not be at all surprised if it is not. But I am trying to find out where I'm printing stuff so I can remove it. Okay, so not super shocked that you know it's still wrong, because we really just changed the order. We don't really do any healing. What is this? 2, 3, 16, 0, 1, 2. So we change this to 16. Wait, what? No. 0, 1, 2, 3. Change this to 16. So yeah, like an etch kind of thing. Yeah. Huh. Excuse me. This is already way wrong. Well, maybe not, but well, I mean, yeah. So here it sees these two, and then now it sees a 2, and what it should do is not that. Because my the precondition of where I did it is that I just care for index, but now it is no longer true because the because we have to do all 3 things together, and that's the tricky part. But still, I mean, yeah, I think we just have to fix this, right? Okay, so maybe the idea here is that okay, left is equal to right is equal to j if I think I used left and right elsewhere and some other stuff. Well, so that just says current left and current right is equal to j if current if L of 1 is equal plus 1 is equal to j, then we merge. So then C left is equal to L sub 0 if, and we also, that means that we remove, right? So here we remove L if R of 0 minus 1 is equal to j, then C right is equal to L R of 1, also remove R. And then we sorry friends, this is live, so I don't know. That's what live is. C left, C right, and then we have to remove these. Remove the remove. It should be consistent. I don't know if it's right. Oh no, I'm always looking at the expected and be like, oh live, you're so good. Okay, let's give a YOLO submit. I think I have some other prints too. No idea where. Oh, there it is. It's like playing 5 differences or whatever. When we subscribe, this is wrong still, but please don't. Larry wants to sleep. Oh, it's too slow. Okay, so we did fix it. And we did, okay. Whew. That took a while, my apologies. But we did fix it, right? So that's what I mean by like problems like this, is that there's so many edge cases, so easy to make mistakes, so easy for things to go wrong, right? And that's why, you know, like, I mean, even now, I mean, we had accepted code. Oh, it doesn't show. We have accepted code, but there was still a wrong answer. So, yeah, an opportunity for you to get 100 points if you're watching it this far in. But yeah, here, I guess my precondition was that I lied, but the precondition was that if only one of the state changes, then this would work. But because we have to change 3 states, so like the precondition, the invariant no longer held, which is that if this is a peak, then that means that if this was a peak, that means that the left and the right are not peaks, right? But because we are doing 3 state checks at the same time, that's not true. When this is a peak and becomes not a peak, then now the left and the right could be a peak, or some combination of, and that's the thing that I had to change. But as you can see, it's not impossible. Once you really understand it, it's not that hard to change. It's just still messy. Anyway, so yeah, so you merge to the left, you merge to the right. Now in here you check to see if they exist, or if they're real segments to add them. And at the peak, we add it to the peak set. And then here's the hard part, if you could believe it, from before, is just the query part. This is the part that I had trouble getting, right? With the left and the right, we constrained it by left and the right because we cannot pick to the left and to the right, because those are not, because you have to be at least size 3. So that means that if you kind of just visualize it, then the number of subarrays that you can choose is going to be shrink, because you cannot choose the left or the right to contain peaks, right? Anyway, so then we set this as you go to M, because I don't know why I changed to M. I think before I had some M related things because I actually had this 4-minute in line, but here we get the total. So get the totals counts of subarray from left to right now, right? So remember at least size 3, and then here we move the peak 3 counts we get in a range from the segment tree, right? So I'm talking funny. I'm just trying to one word. I feel like I'm talking like an LLM, you know, like I'm speaking like 2 words and I'm like trying to figure out the next word, and then I say it, and then now I'm trying to figure out the next word, 1 word at a time, just like an AI LLM. I don't know. Look, maybe I'm AI, but the only AI today is actually idiot. I feel like, because you know an AI would not have taken so long. Tell you that much. Okay. So now this is the things that we talked about, right? This is the left and the right. I think some part about what is hard about this for me is the asymmetry part of it, right? For a lot of implementation, programming, anything, you can impose a symmetry between the left side and the right side so that your code looks the same in either direction. But in this case, you have to impose a direction, and I think I find it tricky, right? As I said, so if the left bounds are here, then there are only 2 cases, right? So yeah, so left bound is inside the range, right? And we binary search for it. So if the left is inside this range, and not sitting at the border, because if it's at the border, then we already removed it here, right? At least on the left border, which is why this is a less less than and not a less than equal to, and then this is if the right side it's outside this range, then now you only have to chop it off from the left side, right? Because we have to extend to remove things from the left, right? And I'll actually, I mean, I know that I kind of already drew this, but I want to draw it again because I think this is hard, because it's hard for me, honestly. Right? Which is that, okay, so let's say, you know, you have an array, you have a peak here, you have a peak here, you have a peak here, and that means that you store numbers here and here to the left, right? Here and here, right? So then now, if you get a range, if you look at something like this, then here there are two things, right? One is that this segment is totally included, which is nice, but then now you have this part and this part. This is what I should have done during the contest. I just was lazy. I don't know. Right? And then here, so then now we have to do two things, right? We have this part, which is not included at all in the segment tree query. So then now we just have to do this math, right? And that's what this is. And there are two cases, right? One is that if the right side is to the right of this of this line, then we just have to add this thing. The other case, of course, is if they're wholly here. So instead of this line, we have this line. Then now the right side is totally within this segment, and so we only have to count here, right? And that's all that code is. That's what this is saying, right? And I'll bring it back for the right side because it's easier. And then now the right side, I think actually, honestly, like I had most of this. The issue that I had was the 3 minimum part. I just, for some reason, did not think about, because I kept thinking about stuff like, oh, we only have one number, then it's a subarray that's doesn't have a peak. But we don't want to count that at all and that's part of why I got confused. Right. But anyway, so yeah, and then on the right side, you know that as part of this query, right, because we took this range, this add here. So then to get this part, well, one is that you have to remove this part, right? Pretty straightforward. You remove this sum. I guess I could have written this another way actually, but then now after removing it, then now you add this back in, and that's it. That's basically what this code does. Yeah. And actually, I mean, I'm going to try something because I wrote it this way, but because we have to add it, because we added back in because we subtracted as part of the segment tree query. But I wonder if I could have just written, because I mean, it's fine. I think you can, where, well, one is you could use test of SL of S index -1 of 0, right? And that maybe should be good. Maybe not, I don't know. Who knows anymore? You know, we should not be using this, but it's fine. Yeah. So yeah, because this represents, because these are all the same numbers, right? It just represents the total number of subarrays within that range. And yeah, and of course you can, by the same principle, just query it at that index, right? Query of this from this to this, which should be the same, hopefully. Oh, well, if you get the parentheses correctly anyway. Oops. This is what happens when you don't run before somebody. I don't know. Oh, it's still running. But yeah, but that's really it. And then afterwards we get the count, and yeah, so you can see that all three are equivalent. And that's it. For each query, we do a binary search, right? Everything else is all one-ish. I mean, maybe there's another binary search depending on how you write things, but yeah. And here, more binary search. So for each query, it is a binary search on n, so it's going to be q log n, right? Of course, there's some n log n sorting in the beginning and segment tree in the beginning, so it's going to be n log n plus q log n, and that's it. Whew, that's all I have for this one. I'm going to show you the non-segment tree code once again. Hold on, I'm going to find it. So there's this, there's segment tree, updating and peaking and stuff like this. Here's query type 1 at the top, I should say, and then this is the handling the left side and handling the right side. Need to be smart about this. I think I don't practice this part enough to write it this smartly. And this is the update. And as you can see, it is a lot of code. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me sub live in the contest now. I'm making a silly mistake, so that's why I was worried. But okay. I mean, it took 16 minutes. Not great, but I mean, we had the idea, just implementation was slow. But okay, let's not waste more time then. Let's go to Q4. You have an integer array nums of length n and 2D integer array queries. Subarray is peak subarray. There's at least 3, and there's a peak. Okay, fine, good enough. I can process queries of 2 types. Calculate the number of peak subarrays fully contained. Do they have to be non-contiguous? And then you have an update. So it's probably like some weird segment tree thing. Is my first thought. Because of the update, yeah. This update applies to all subsections. Okay, yeah. Return an answer. Okay, let's take a look. We do 0, 3. And K is. I mean, it doesn't have to be segment tree. I guess it couldn't be. Because you have to just keep track of the peaks, so it could be some whatchamacallit, sorted list management. But either way, it's really annoying. Is probably my guess. So 3 elements. Okay, so we know that 9 is a peak, right? How would I want to handle this? I mean, it's all a data structure, right? I'm just trying to think what's the best way. Do we just keep track of the peaks? What happens when you change a number? When you change a number, it can... When you change a number, what happens? You have to do... I mean, obviously, it can change from a peak to a no peak, a peak to a peak, a peak to a no peak to a peak, and no state change. Right? One of the 4 possibilities, but are those really it? Like, is there any action at a distance, or is this And it has to be peak subarrays. What does that mean? I guess I just have to be linked to it. But does that also double count stuff? Like, they don't have good examples here. I wish they have one good example, because subarray, like, is it there exists an index k? And what I mean by that is that, let's say you have 1, 2, 3, 2, 1. Obviously, this is a peak, and then now you have, but the peak subarrays, they're like 1, 2, 3, right? In theory, depending on how they write it. So that's why I'm like a little worried. All right, let's see if it's in one of the examples. Maybe this one. 6, 2, 7, length 3. What? Oh. Update nums 3 to 0. Okay. 3, 6, 2 is 1. Oh. Okay, so this does answer my question before we implement it further. So then the thing is, then now it's not just keeping track of the peaks, right? Is you have to keep track of the peaks and how far they extend to the left and right. I mean, I still don't think there's anything too tricky algorithmically. It's just all data structures and also all edge case type things. You probably can implement it in a sort list. It is just annoying. And then combining it, right? So then you have. How do I want to write it though? I mean, you could think about like an up segment on and a down segment, and then what happens when you change a number? Do we want to just keep track of the up segments and down segments? And how would that work? This one is just not that interesting. I think that's my problem. I get it's very hard to get excited for it because it's just not that interesting. But I'm just trying, like, I'm just thinking of all the silly ways there can be silly mistakes and such. But like, there's so many. These problems are always kind of okay. But there are a couple of design decisions I can make to figure out how to implement this. It's either we keep segments, we keep the peaks, and then what happens when you take one? You just do the math. Is it on the left segment? Is it on the right segment? It's either that, or we just keep track of the left-right independently. I think those are the two main things that I'm thinking about. And they're both really annoying. I could see myself getting like 10 wrong answers on some of them. Definitely not a 1 minute problem, but of course, for some reason, Leetcode does not consider that cheating. How do I want to write this? This is just not an interesting problem. I mean, it's an implementation problem, but I don't really have patience for it today. It doesn't seem like. How do I search? I mean, there are a lot of things that are annoying with this one, but okay. And then you have to do like edge cases to that are not peaks, right? For example, if you have or just like a number like 1, 2, 3, 4, 5, you only have the left segment and no peaks, so we have to handle that as well. Can I wrap them in infinity? I guess so. Because I wrap them in I mean, it doesn't matter. I guess we can, and it doesn't change the answer. But it just I don't know if that helps. And also, that's not I mean, that's only if you count one of these things, right? So then the other thing is, oh no, maybe not this one. The other annoying thing is that if you have something like this, and then maybe just another one, then now if you do it this way, then you have to get the sum of these things, which you need like a segment tree or something. I don't really want to do these kind of things. It's just not really super interesting. But because we've done so many of these things, but it's just annoying. Okay, wake up, Larry. Yeah, this one's not interesting, and I don't have enough focused on it today. But let me just grind it out. Yeah, so I mean, so you need a segment tree that you update at a point. You do a range query. Um, maybe I don't. I don't know. I think I was just thinking in my mind like, if you don't want to do it and not knowing how to do it, they're the same thing, you know, in all practical purposes. And maybe, you know, I was just resolving like, maybe they're right. Maybe I'm just lazy today. Maybe I should have messed up. But I mean, and it may be true that I don't know how to do, or I cannot solve this within the time anyway. It's just that this is not super interesting. So apparently 600 people did get it on time. So you look at, you know, some of these 600 people are able to do it in 2 minutes. The best people in the world. Then I don't know. Today I have no grind. I just have to go run later. Yeah. I really have no desire to do it. Do I want to come back later? I don't even know anymore. I am not giving an honest attempt on this. I mean, I don't know. I'm just trying to see if I understand anything. Really not much to understand, right? It's just do it. We need a segment tree, we need to keep track of. Okay, let's not worry about the queries for now, and then just work on the data structure, right? On the update, right? On is peak or not, right? So we have nums. Okay. Oh, I really don't care. Sorry, friends. Sorry you have to see me like this. But yeah, okay. Let's just write out a race naive thing first, right? How do I do this? I'm writing it so like lazily too. Okay, so what does this mean? It means that this going to 1.3 as a left peak of 1, left streak of 1, right streak of 1, right? And what happens when you change? Let's ignore the queries for now, right? Oh, okay, what do we do on updates? This is weird, right? I mean, it's. I think what I want is actually instead of this. What do we want? We want the end of the streak. Right? So okay. What am I writing here? This is why I need like a helper, right? From 0 goes to 1 thing. Should have a second one. Oh, because it doesn't end, so you write something like this. It starts at 1, which I guess is true. No, it isn't. It goes to. Looks at this, and then now it looks at this. It goes down. It starts at I, and because of this zip, that's why. And then it goes to 1. Maybe that's actually true, because 0 is these two, and then it sets 1 here, even though technically it should be the next one. Okay. Something like that. Right. I have no desire to write this. This is like so boring. And not like I'm not engaged at all. Maybe just one of those days. Because now it's just like all state management and stuff like this. It's not that interesting. It's bookkeeping. It's the idea here is that this should be a sorted list, and then and just do stuff to it, but it's just not. Maybe I think what I want to do is to write like a general thing for solving a lot of these type things, of like handling the merge and stuff like this for me, but I don't know. Because basically the idea is that this should be a sorted list. No. Oh, yeah, no. The other parts are right, but you could even put the end, which is here. The same thing, uniquely determined, but maybe slightly easier to read. So 0, 2, no, just now you have the left segment, right? From 0 to 1, 2 to 2 is 1. Start is I plus 1. Oh, this I isn't right, it's outside. So n minus 1. Yeah, because this I is weird because I'm using zip. Maybe I should just use actual I. Okay, right. And then now, if it goes up, we split it up, stuff like this. You may lose state, you may have other things. That's why it's annoying, and yeah, I mean, yeah, you just do like this curly. If it's equal to, then well, I mean, okay, you want to update num sub. We have num sub. Okay, so index value is equal to AB, and then basically, if just a lot of states, right? So if okay, fine. So previous I'm thinking whether I could use more segment tree, but maybe we can, but I don't even know. What am I doing the previous stuff? So okay, so was this part of a streak? Left streak. We're just on one side for now. the other side should be straightforward. If this, I mean, that's not necessarily true. I mean, a lot of off by one potential, but in theory, the idea should be right. Right, so here we do a left up bias. No, we could even just do something more basic, right? So if num sub index has to be strict. Wait a second, maybe I'm misunderstanding this a little bit. Because there has to be a peak, right? But it's actually, I think I misunderstood this actually, because I thought it had to be a mountain, which is maybe not right. Meaning that, I mean, I don't know, maybe I'm still, so maybe I've gotten it wrong anyway. But what I mean by that is that, like, you have something like this, let's go with this 4. Technically speaking, this is a K, right? This is, what is I and J? Oh, I is just a whatever, the input. But because K is a peak, technically speaking, all of this is a peak subarray, right? Am I confused? So okay, so that means that I misread this because I thought I had to go down and up like this way. But actually, I think now that I'm reading it again, and I mean, it's still bookkeeping and we have to track, but maybe not the way that I've been doing it. I doubtful now, right? Because 4, then now on the left side, so basically it is saying that wait, what? I'm so confused. Okay, now maybe it makes it easier though to implement, because I was thinking a whole different thing, but of like doing the left side and the right side and then keeping states in the segment. This may be a little bit different, because then now it just given a sub array whether there's a peak or not, right? I mean, and every sub array has a peak unless like, you know, you have something like this, then that's not the case. But so can we process that? So what makes it so that okay, maybe this is a different problem and I was wrong on how uninteresting it is. Maybe it is interesting, I don't know. But okay, so that means that I thought it had to be a mountain, which is different from a peak, I suppose, now that I think about it. But okay, so the only thing that cannot happen is if you have these things, maybe like a plateau or whatever, if you go by geography. How many counts of, so okay, so let's say you have this one, right? And how many good subarrays are there? There's this and all the stuff that's inside, and then that's it, right? Because you can't go to the left. Or, no, even this no, Larry. Even this is a peak subarray. It means that these two are not peaks, but this is a peak. I mean, I'm so confused. Let me look at, see if the constraints are anything weird now. The examples don't really help, but I guess this one kind of. Yeah, I guess this one kind of shows you. I just kind of stopped at a second. What's K again? Okay, it's the index. Yeah, even though this goes down and up, I missed it. Okay. So then, what is not a subarray then, or not a peak subarray? If it has two elements, is there any subarray inside this peak? Yes, right. So if it does not contain this, meaning if it's this, then this is not a subarray, right? this is not a subarray peak, but this is, even though 4 is not the high, or 4 is the highest, but it's not a peak. So the peak doesn't have to be the highest because it's not a mountain. Okay, let me now to think. Okay, so it's not just implementation for me for now. I just kind of misread it, and wow. Still feels like a bookkeeping problem, but maybe it's a different one anyway. What does it mean? Maybe I don't know then. Cause okay, so this is a peak. What does the peak mean? That means that any subarray that contains this number is good, right? And in theory, if you don't have a query and you do a one pass, then you just do a sliding window type thing or whatever, and a gate on the left side. But anything that contains this number, and of course one more number to make it a peak, is a peak subarray. And how do you do this? But this is not. How do I know something is not a peak subarray then? Well, it just doesn't contain a peak, right? So it means that, okay. I don't even know how to solve the, I mean, I guess I said sliding window. I was going to say the no update version. Not the update's not that interesting, but I mean the subquery, the query version. Like if you have no updates but multiple queries, can you solve it? I don't know. I mean, of course there is a solution, but I don't know if I know how to do it. It's my point. This is what happens when you're too tired. Okay, so we define what is not a peak. So we do a search here. So it is, so okay, let's say this is a peak. That means that and let's add a peak here, right? 3, 2. So this, everything on the left side is a peak. So then now you have this peak and this peak. So then now the whatever and choose 2 here subarrays are not peaks, right? So then now, so instead, we need to track segments of not peaks. That seems easier though. Because then now if you change this to this, then now this is a peak. Then now you just divide these two. Okay. There's still a lot of like weird edge cases, but I think this is much easier to do than the other thing that I was doing. Right. Okay. Fine. Let's give it a spin. This seems at least doable. We want it from I to n minus 1 because the nums of I. So this is a peak. Oops. Right, so this is a peak. Okay, I think I get it. Okay, so this is a peak. So maybe we just let's start with peaks 0 to 0, right, and then now we do maybe segment, right? I can't believe I misread this for a long time, but okay. And so then now we want to say from the beginning to peaks of 1 maybe. Okay, so the states are easier to do for sure. But now only 32 minutes because I spent half an hour on the other way. How do I write this? So we're basically literally drawing segments. And then there's a segment tree portion as well. Okay, so the full sub-array query will be n choose 2, and then we just kind of sum up the segments. So then you have segments that are from okay, so this beginning of the segments. Okay, that's fine. Yeah. If peaks of 0 cannot be equal to 0 because you cannot have 0. So then you have this, and then the length, maybe the length doesn't. Maybe just leave it this way. Right? So you have segments with no peaks. So then this is the case. You have -1 for inclusive, and then now for AB and then now we add from A plus 1, B minus 1, right? And they cannot be next to each other. So okay, yeah, because that's by definition. And then we have one more maybe at the very end. Peaks, and then n, maybe n minus 1 actually. And again, that cannot be because that's just the way it is. Oh yeah, again. Okay, so then now we have streaks of 0 to 0, 1 to 3. Huh? Are the peaks not right? Oh, this is at the end. So yeah, I forgot to do the +1 on here. Okay, so this never actually went for that one. That's why. So from 0, 1, 2 to 3. That's true. There's no okay. And then now, what we want to put in the segment tree. Now let's not worry about segment trees there. Let's do the updates first. I don't know why I delete that part, but T and B and queries. T is equal to 1. Ignore it. Else. Okay, so then what do we do, right? So let's make this a sorted list as well. Let's make it a right, let's do this, and then we get peak set. I don't even know if this is necessary, but it's fine for now. So if index is in peak set, okay, so before peak is equal to this, right? After peak is equal to we is, I guess we can change zeros. Oh, but you have to do it for the you have to check the border numbers too, right? Okay, fine. So then now that is annoying. How would you do it? Because the peak status can change. After peak is equal to we is We could do it. We could do it. We could do it. Annoying, but we can do it. Thumbs up. I mean, yeah, stuff like this is also very annoying because you have to do like right. So then now if it doesn't change, then it doesn't change, right? So if before peak is not equal to after peak, I'm probably not gonna finish in time. Spent too long on the wrong problem. Still annoying though. Then now, so they're the same, then we are still not done, to be honest, but let's say for j in range from index -1, index +2, right? If j is doing it and then knowing when to update is weird, actually. Okay, so then we update this first, I suppose. And then we don't keep track of this. It's definitely awkward, the timing of it. Okay, fine, right? But so then now, if before peak is not equal to after peak, then there are only two cases. If so then now we attempt to merge the two adjacent ones, right? So we already removed j. We also have to handle the sorted list. So we do a I think the way that this is very annoying. I'm just a little stuck on how I want to write this, because we have to do it for 3 of these things. I think this is fine, maybe. Okay, so if it's before peak, then we have to remove it from have to bisect search the J. And then no, we want right. Well, okay. So then now this is a bisect right basically, because I'll never write it explicitly. So then now our sig index is equal to this. If this index is -1, then this exists. Then now, what are we doing? So it's before peak. So then now we're merging these two. So then S index merge S index -1 and S index, right? So then now S index -1. Oops. L is equal to this, right is equal to SL S index. Would this always be true? Yes, because no. What happens if you're updating the last element is what I'm trying to do. Well, the last element would never be before peak. Okay, so this should always be true. We'll just, I mean, I was gonna write an assert. But I think technically this would just bound anyway. Okay, so we combine these two by taking remove SOL, remove right, and then LZ.L, L of 0, R of 1, right? And then if not before peak and after peak, then now what does that mean? That means that you have it in one segment. So now you're inside, you go to the next one, -1, right? Okay, fine. Again, I think this has to be true, but well, like this cannot fail. But then now let's go down here. Original to so J is the peak, so it's J -1. Okay, so I think that's it. Maybe not. I don't know. Who knows anymore? But I want to see it. No error, please. Okay. This one. Oh, if before peak. That's a slight mistake though. Okay. Alright. So this goes to 0, 3 to begin with, maybe. Why is that? Because we update 1 to 0, so yeah, okay. Maybe that's true actually. Let's see the before. No, it's type 1. No. Type 2 is convert this to a 1. 1, 0. Yeah, change. Right. Oh no, I'm looking at the wrong one. So then change it to this. So yeah, so 0, 0, 2, 3, 0, 3, 0, 1, 3, 3. Is that right? 0, 1, because this is a peak, and then 3, 3. Okay, so that's right. And then after I'm guessing removing this one as a peak comes 0, 3. Alright. This one we have 0, 0, 2, 2, 4, 4, and then changing this one to a 0. Okay, I think one thing I want to see is we're not going to get it on time because I'm too dumb, but changing 0 to 1, changing 2 to 2. Set. Okay, so these are the things that I was talking about, but there are no peaks. Oh, okay. Well, I mean, I think that's fair enough, though. If there are no peaks, then it's just the entire thing, right? So okay. Yeah, okay. So length of peaks equal to 0, then sl.add 0 and -1 else. Okay, so that's actually a good catch. But yeah. So then it goes 0, 0, 4, update the first one, update the second one. Okay. So I think now we're in a good place. Was easier than the other thing that I thought I had to do. Okay, so then now, how do we handle it? Everything else is query, kind of. I mean, I think we have to do segment tree here. What do we need to do? We need a point update range query segment tree. Let me find my thing. Is this a point query? No, I have to find that one. No. Did I say point query? No, range query point update. Yeah. How do I do the math? Okay, I see. I think I could do the math that way. Okay. 14 minutes. I'm not going to get it done, but that's okay. I spent too long because I was reading. I misread the prompt altogether. But that's okay. So then now what we want to do is when we add, when we subtract, we want to sl.remove, well, not sl, segment tree. Where's my segment tree things? We don't need this anymore. Just end, right? Okay. So then now when we add, do I use a helper? Maybe. Left, right. Then now we want to store on left. I mean, that's fine. And then we want to store sl.update. How do I forget which one it is. This is the 0 based one. No, this is the 1 based one. So oh no. I this is the one where I have it done away. So then we update. Where am I? L. So the number of elements. Choose 2, is it? Is it choose 2 or because it could have one element, right? So just and count. Let's just say. Do I want update or set? Oh. I mean, I forget if this one updates, it sets. Okay. Where am I in the code? This is gonna be. I don't know why I wrote that. It's I don't I always forget if it's +1 or -1. Okay, we have 3 elements. Then now you okay, we have 2 elements. Then you have 3 ways to do it, and it's 2 minus 2 times +1 over 2, right? So okay, so it's +1. Okay, right. So my removal or for original. And then we want to update left to 0. I guess that's it, really. And also, actually, just removed SL part because I named it exactly that. Okay. Just run it real quick to see I don't run into any errors. What is this Leetcode thing? Oh, right, because okay. It doesn't crash, so that's good. So then now the query is just a summation, right? It's not quite that, but we're like most of the way there actually. So that's kind of cool. I mean, this is not the right answer, but I am just gonna write it for because this old, oh no, this, well, I mean, it's just wrong, right? Because I shouldn't use n like this because this is confusing. Okay. So then now count is to go to and then it is going to be m minus or count minus this. It's not right because we don't care about the edges enough, but it's a good start. Maybe maybe not. Why is this 10? Why is this 10? We could also have a lookup thing just for testing, right? T for testing. I mean, by definition, this should overcount, but yeah. So negative numbers I expect, 10 I do not. So int object, okay, we use this somewhere. T for testing, but apparently my laziness. Okay, and then now we want to print test it. Okay, so that's not right? We do not. Oh, because I didn't set the initial ones. That's why. Okay. Oh, whoops. Okay. I mean, this is slightly better, I suppose. Let's see, right? So you have 1 here, and then these 2 will give you 3 starting at here, right? Okay. and then afterwards is a 10 starting from def. Okay, so then why is this wrong? Let's see, right? We have count, we have query. We have 6 minutes, we're not gonna finish because I misread it, but that's okay. 10 is right, so 10 is right. So why is this 2? Why is this 2? I think I'm undercounting a little bit. I'm undercounting the overlap with the 3 because this segment is 2, but it extends one more, including the number to the left and to the right. Okay, fine. Right, luckily that's why we have an abstraction here. Okay, so then now this is the number of numbers, right? So if y plus 1 is m increment by 1, because we can extend, that means that there's a peak on the thing, and then left minus 1 is greater than equal to 0, and right? Okay. All right, I mean, this is closer, not quite right. So 3 is because you have 1, 2. Okay. But why is that 6 though? What is printing 6 again? It should, I mean, the segment tree is not including the queries. Okay. Huh. 0 to 3, so that's the entire thing. So why is this not, I mean, yeah, why is this not? Is my segment tree wrong? Maybe. I always forget whether my eyes are like 0 based or 1 based. I think it should be okay though. Did I do SL sorted? No, it's here. You did this. It has a 3. I mean, the 3 is wrong. We can fix it, but that's not right. I mean, this is maybe, I mean, it's not quite right anyway, but because 3 by itself is, but then now you double counted the 3 by itself, so just minus the number of peaks, which we can do actually, because we're double counting the peaks from both sides. Okay, that we can do, but the query is still not right though, that's the thing. So there are 2 things we have to address. One is the we have to subtract out the peaks. This double counts, we have to subtract out the peaks, and but then here it's just not querying right, which is a little bit weird. Let me make sure that yeah, 0, 3 we do update it. I mean, we have it here. What is my segment tree incorrect? Let me do. Is my update wrong? It's been a while. Well, now I have no chance. I was hoping I would at least like you know, have a fighting chance to getting it close, but we're definitely going to go over by like 10 minutes, 15 minutes maybe, especially because we're debugging things like this. But does that work? I don't know, I don't get it. Maybe the way I did it was wrong. Update, I. Yeah, and now we're out of time. Oh well. Alright, let's take a look real quick. I don't know why my query is not wrong. We spent a couple minutes there. 3 is right, so then why is the sum wrong? Wait, am I printing the right thing? Am I just confusing myself? Maybe I am just confusing myself. No. So okay, so 0, 0 is right, but this is wrong. Gotta be more. I gotta have a more reliable one. Why? Shield and -1, yeah. 7, 3, no, 0, 1, that's just a no, that's fine. Huh? Query is the thing that's wrong. I mean, it's not even just that, right? It's like 0, 6 on this one is wrong too. Wait, is it? No, maybe that one's right. Maybe this one is right. Actually, no, this is right. I'm confusing myself so much right now. Because 0, 3. Oh, I am dumb. I am dumb. Why am I using max? Larry, what are you doing? Why was I using max? Huh. Why am I using max? What are you doing? I mean, my template was max, but then for some reason I just... I don't know. Just one of those days, I suppose. Query is going to be... how does this work now then? I always forget. Okay, so do you just add the both parts? Maybe just something like this actually. I think that handles it a little bit better. I can't believe I'm just dumb. Oh, I mean, I can believe that part, what I just said, but that is pretty dumb. Okay, so now we have 10/9. Okay, so this is what I expected. It's still incorrect, but in a way that I expect, and we can do it because we double count, we have to subtract out the peaks, right? I guess the way that we can write it is just by... Can we do it that way? I'm trying to think. I mean, it's fine if we do it that way, but I want to also think about, well, okay, now we know that we're intentionally being wrong, but I have to incorporate fixing the other thing first, which is that we're cutting off at a segment, right? The left, right, yeah. So because here, for example, if we have something like this, this 6 implies that it goes all the way through. So on the left side, I think we are okay because it does not overlap. Well, no, we have to add back in on the left side, right? So for example, here we have a segment that goes from, where are my segments at? Yeah, for example, we have something like this. And now we want, and this is, yeah, so we have someone like this, but then we want, which one is this again? Example 2. Yeah, from 0 2. So from 0 2, this would not be that. So from our segments, we can sort and then, yeah, just take the prefix of the but then now, okay, so that's one direction we have to fix, right? So we have right, but we also have query right? And then basically, if we search for right, it's inside that query, then we just skip it, right? Yes, okay, fine. Right, So then now we look at the previous one, and then previous one to that, right? Because the previous one always exists because we're bisecting right. And then previous to that, we want so that's the actual, so that's the segment. So we have query right is equal to this, the right side query right. Now we update this, and we might fall out of bounds actually, or just nothing happened because we gated it. Yeah. Else, because you don't have a segment. Oh, because it's 0, 0, but technically it should be -1 because it doesn't contain anything. Okay, and then -1 crashes this. Let's just say we have cat, right? Oh, right, we're still putting it. Right, so then now it does 6 instead, which is fine-ish for now. Now this isn't right. This should actually look at the, okay, so now we know the segment, so this is the segment, not trying to limit this, right? So then now we want to get the count. Oh no, this part is right, but we have to do the math on we have to, so the query is one component, and then we still have to do the part that sticks out. So then you have SL of SL index minus 1, so 0, SL of 1 minus this, right? I should have just done like okay, I still can, so let's just have a helper. This way. Maybe that's fine for now. Yeah. And this isn't quite right. This should be, I mean, that would normally be right, but we actually want the query, right? Yeah, okay, so that fixes that kind of. And so far we only handled one side, so we have to handle the left as well. So this is the part that was always going to be annoying that I knew. Okay, so where were we all still? This is TDD, baby. Okay. How do we want to look at this? So here we do still sum up to the... No, we don't sum up to the left side of number of things to remove. So it's the same idea here though. Okay, fine. So we do okay, so Q left is equal to left. Okay. No, this is different. Don't copy and paste, Larry. So it goes to the next one. So then, yeah, if S index is this then Q left is equal to S. Okay, so if it exists, then it goes to the next one, and then we're just happy with that. But this part, it is going to, it's going to be S index 0, and we should be happy. Otherwise, then now, but now we also have to do the previous one, the one that contains this, and then we just subtract from SL, S index minus 1. No, we want the left, so this is the right, and then the left is going to be just the left, right? Ah, so close. Did I take the wrong one? 0, 0? That looks right. I mean, maybe it's because of this change. So that's okay. And we got 6, which is not okay, but why is this 2? Because the left query is 0, 0 goes to 0 as part of the things. 0 goes to 0. What does that mean? What does that mean? What does that mean? Okay. So now as it... No, this is fine. But maybe it subtracted here, so that's fine too. So, okay. Okay, so it doesn't go through the set tree. So then what? Why is it? Why is the count so bad? Why is this 6 then? So 6 is just 4 choose 2. No, do we choose 2? 3 numbers, 6 things. Maybe that's right. Oh, no, 4 numbers, 6 things. Is that even right? Actually, it's 3, 4, 5, 6. I'm so tired. These farms are just dumb. It's not interesting. Well, I mean, okay, I misread it, but still. I still stand by it though. I mean, okay. Seal should capture some of it, but so how? What am I hoping to remove? I'm hoping to remove the, so the 3 here doesn't really, or the query going to 0 doesn't make sense, right? Because it goes to 3, 3 is at the end. So then now it goes to 0. Right? But then because this is true, okay, so it does go here. Wait, so what was it before? You have 4 objects, 4, 5 is 10. Okay, so you have 10 and reduced to 6. Okay, so I actually did the math wrong mentally. But, okay, so there's 3 here. Is that right? You have 2 objects. Oh, I see. Because this doesn't do the, this thing that we did with the, including the number, the peak. Okay, maybe I could factor that in. Should I factor that in? What else do I call this? Is this the only place I call it? I think we should do this anyway. And ironically, that makes this part consistent now. But we double count on the peaks. Maybe. Maybe because there's just a lot of cases. Okay, so now you have 1 because we double count the peaks. This, the negative 10 is clearly wrong. Okay, so here, entire thing is 10. Okay, and then we just keep subtracting somehow. Print. Query. Did I already do something? Let's count. Okay, so 10, 10. So this is good at this point. But is this also subtracting? Is that right? Because this is the left side now. So the right side is saying yeah, this is the case that I was worried about. So maybe that's expected in that they're both the same segment now. And if they're both the same segment, then you have to add in, you have to add back in the overlap of this segment. So how do I write that there? Add it back in. All right. Well. Is that the same segment though? Maybe not. Because basically the left side it's saying the left is in the same index, right? So maybe we do this is just so not interesting. I mean, I could. The way to do this is by first principles. I think this is all right, which is surprisingly but nice. But the math part, I'm not. I mean, it's just drawing it out, and I've been kind of lazy. Yeah, how long has it been? 2 hours for this problem mostly. Why is this wrong for the other ones? It actually seems to be right for Q1, but Q2. My terrible debugging is not helpful. You start with 6. Start with 6, you minus 3. Why do you minus 3 on the right side? You have these two and you have 1. Okay, fine. I'm at here again. On the left side, maybe do the same thing. Oh, this is 6. That's why, but why? Just 1, 1. 1, 1. Oh, because when I subtract it from the left, it's not M that I have to care about. It's the bounds. And okay, that makes sense actually. Hmm. So this is asymmetric in that regard, right? Because it is greater than 0, but it's not 0 that we care about. And also what I should have done, and instead of doing on both sides, just be consistent and do it on one side. I think that fixes a lot of things, but I just don't really have the brain power for some of this. And that makes sense. Because for one of them, this makes sense. For the other one, that's actually why maybe this is 3 is no 3 is right. 6 is not right. It's only 3 is right because this is on the edge. So otherwise, this is wrong too. I think this doesn't make sense. I think what we need. I'm just rethinking whether I need to rethink how I'm storing everything in general, and doing calculations that way. The beginning thing, yeah, we do want to keep the peak, so the thing makes sense to a degree. Right, but also not, because this 8 should have 3, but it thinks it's 6 because it tries to extend to the 9, but it should just try to the right way is to be consistent, I think, so. To do something like this, but then we have to handle I think this makes. How come I cannot undo? Oh well. I think this makes sense for inside, maybe, but for here it doesn't really make sense. Because the number inside the segment tree includes the edges, so we have to be careful. Just cannot reuse that one, I think. Okay, I think I see it. Because then now here, instead of doing the things I have here, okay, I think I see it. Then now here, add alright, this is too confusing. Wipe out. This case analysis it. Okay. Do I want to store the thing that's inside? I think so. And we could just add the. Yeah, no, we don't store it then. And then we just add the peak. No, you need the peak. No, you do need the peak inside. So then this add. Actually, I think this add is consistent. Well, how else are you gonna do it? Because okay, so at the border, the peak will contain the length of the thing, right? So you have to add it. If you don't add it, then now you do it to the right, so that each segment contains the peak to the right. That's the thing. The last number cannot be a peak. Okay, that's right. Okay. Now there will be no double counting of the peaks, but now we have to be even more careful, right? Because this no longer contains the left, but this contains the. And now a segment. How many segments are there containing that one? Could be a lot. No, just n, the length of the segment. Yeah, because this is going to be the limit. Right, okay, fine. Maybe that's fine. So then now what? Alright, let's start again. We've queried from 0 to 3. No, but then you have to count the number of peaks. Right, so this is 2 peaks. The thing is that this peak, oh no, this includes this peak, so then we just count, is that right? 2 peaks? Like, do we add back in the peaks? If we add back in the peaks, this is just exactly the same. Right, like as we had before. Just doing it differently, which is fine maybe. No, because it's not just adding 2. Because this peak contains 2 things, right? It's not just it's not just containing 1. So you do need to do it the other way. What did I do anyway? Oh, I did the thing here, which I didn't do on the update anyway, but it's okay. So you can't do it this way. But it's not quite like that. You need this to be what? Oh, yeah, because we didn't do the how do I want to write this? This is just so annoying. I suck at math. There's a difference between interior borders and exterior borders. That's why I'm trying to figure it out. And that's where I'm struggling with. My brain is too tired. Maybe I need a break out of my soda. Okay. I'm just trying to figure out what I even want to do. Like I'm going through all the permutations in my head, and all of them are just kind of like as annoying as I just did it, and I'm not even, confident that it would be 92 degrees. I have to go for one night. I'm just looking at my temperature. It's not looking good. But can this happen? Okay, maybe that. I mean, that wasn't our issue anyway. Okay, so let's say we have is that good enough? Maybe it's fine. That's what I had, right? Alright, so we're doing the left side first. Then okay, so if left Which direction is it? No, it's the other way. No, I think I'm confused. Okay, so we want. I don't know if it should be equal to or not. I don't know. And then guess it doesn't matter. And now, okay, I see. Then we can add back in the okay, so if you have the segment, right, then now you subtract you add this back in actually, not subtract. What am I writing like this? And you subtract out. Something like this. Wait, no, that doesn't make sense. Okay, so you have this point here, so this is SL, this is the SL left, and then tail naming maybe. This is the SL right, so then now we're saying that left is here. Then I am confusing things, so if left is here, then we add back in this, right? That's what I was saying, right? Or we subtract back out, I mean, we add it. Yeah, okay. I thought I had this though. Okay, and then I'll do the other case like if I'm trying to do it. So you have this. Now you're on the right side. So then now, because we store thing here, so how does that go? So we do a search, it'll be the next one, it comes back, right? So we have to this is the one that I think I confused, you know, so this is not intent correctly. We want to add back out the thing that we destroyed, which is this thing. and then just resubtract. Something like this. I'm so tired. I mean, we had some variation on this before. Problem is that this is and now we have to do, I'm missing a case, maybe, I mean at least, where we have left, right, we're here, oops, here, oops, here and here, then what? And this query will return nothing, right? So the count will return 0, and then now we have to add this, subtract that. No. Okay, what is the right way to do this? No, I mean, there's no subtracting, it's just this part, right? Well, I mean, this part is going to hold true, so then if right is outside, then we do this, right? So if else, then everything is good, and we just do this, right? Something like that. Okay. Still probably off by one somewhere. I don't even know anymore. Okay. Why is this still 6? This is still 6 because this is now 1 and 3. I mean, I'm not even sure these other things are right, but let's see, right? I mean, it's 1 and 3 because we don't count the peaks itself. How do I do it? I have to track. Okay. Oh, right. Count is equal to is that right? Yeah, I mean that's the full count. That's right. We do the query. I did it this way so that it doesn't overlap the thing anymore for, say, this one, but I mean it looks more realistic-ish. I don't know. Hmm. So tired. Sorry, friends. I'm just tired. Okay, so this is definitely right. Is this right? This is kind of right, but it's not set up correctly. Oh, wait. Why am I being dumb? The double counting doesn't exist because it only has one element. Because it has to be of length 3. And I put it here. So this is actually wrong. And this is actually wrong, actually. Right? It is actually -2 because we have to at least length whatever. I mean, numbers look better. Is it right? I don't know. Okay. So then I don't have to worry about overlaps because, oh man. Okay, that's just me being dumb then. Then now we don't have to do this. Well, no, now this is all zeros. That's wrong. Oh, this 3 part is right. What am I removing? Okay, wait, let me. Forgot about. It's not n choose 2. That's right. So then now all the possible. There are only 2. So there are only 2 possible arrays. So why is this returning 3? Is my math wrong? So for 4, it should return 2 times 3 divided by 2. So what is that? N minus 2, n minus 1? Then I have this. Let's see. So this should actually. I can't believe I missed some silly detail. 2 times 3 divided by 2. No, then it's no. Oh wait, no, I'm dumb. 3 is right, 3 is right. I am an idiot. And I am just so bad today because I forgot the 4 element away. So 2, 3 elements, 3 length things, and then 1 length. Okay, so this is 3. Okay, so that's actually a little bit better, right? And then now this is okay. This 0 is actually right. And this 2 is actually, this 0 is also right. So then what are we removing? We're removing the one bad one, which is 3, 2, 4. Man, I can't believe yeah, okay, I'm just being dumb. I have a lot of print things, but where's my print? Where's my print count? It's somewhere, right? Or maybe I removed it. Okay, I did remove it. So okay, so then now you have 0. So that means that this part is true. Whoa. I mean, this is it. Okay. So then this is the case. So then it subtracts stuff, but it's all zeros. The right side also true. And that right is inside. So we subtract the 0 that's inside, and then we add. That doesn't solve it. Is it this? Does that do anything? Nope. So this is only if it's sticking out. I mean, I don't know. Okay, so 3 we confirm is correct. We have to subtract 1, which is this substring of 3, 2, 4, which is what is it? Is this right -1? Nope. I need a brick. I don't get it. What am I doing now? I don't get it. Just this streaming now. Got this one right, I guess. But like everything else, you get one ring right, everything else is still wrong. That's okay. For what is the expected? Okay. Maybe, how long has it been? Maybe I would take a break and, wow, it's something like 2.5 hours for this one. But I'm just tired. Just... Maybe I need to map it this way. Alright. That's also wrong. All right, so, oh, no, I'm looking at the one column, getting excited. But, I mean, the 0 is right, but the 2 is now no longer right. Yeah, why is it 0? Maybe it is. Something like this, maybe -1. Wow, I'm missing like 3 letters, and I'm passing out. Let's see. So, wait, where are my print statements? Okay. So yeah, 0, that's always going to be wrong. Oh, okay. What? I don't know if this works. I was about to just give up submit, but I guess I still have to remove some count statements. That was close. Yeah, well. That do. Oh! I mean, I had most of it for a long time, but I knew that this was going to be, I mean, one is that I know that this requires carefulness and thoughtfulness and stuff like this. And I don't have it today. Just so tired. And I still have to go run 8 miles, but this actually turned out not to be so bad. I don't know. I just confused. I think what I end up doing is that I mixed up using it here. Like this one and these ones. I think this confused me a lot, and I don't know why they cannot be consistent. But that's why I guess I put it in here. Because that's the total number. Gap is, I guess everything in between. I guess that makes sense. But yeah, why don't I double count? I thought I might have to handle it. Oh, I think I misunderstood. I see. I think I got a little confused. Maybe not confused, but I didn't like articulate it well. And I think that's where this finally, yeah, I missed a really big insight. I mean, it's obvious once you think about it, but like I don't know, did not. But if you have something like, I don't know, this, and you query for, say, here, then this number, no matter what, cannot be a peak, right? Which is obvious. Like we've done enough about it. But because of that, then my initial count is incorrect because we don't care about this number at all. So we're just querying for basically the inside and outsides. And I think that's the part that I got confused about, because I think what I should have done is actually just to like yeah, and then now I can use something like, because I think that's where the confusion is. And the other way, I mean, I don't know. And I was just trying random stuff. Does this work? I hope this works. Otherwise, then I'm just, oh no, not this one. I'm just as confused as before. Even though I... okay, I think I just got confused a little bit. Well, assuming that this works. Where did I go wrong? I might have just like forgotten. Oh, there's one case. Okay, well, let's use this. Okay, -2 is clearly not the right answer. I see. So I think that's the, I got so confused about this one. And some part of the reason is yeah, part of the reason is just because I am very prone to doing off by ones even if I did the math correctly. So when you're wrong and you don't know if it's your algorithm or your code, that is a recipe for disaster. And I had so many silly mistakes, like using max instead of adding, and I had to debug that for 10 minutes. Maybe that's just a sign of today. And then here, yeah, that's right, because you don't care about things on the border, so they don't count. And I was trying to do some off by one stuff for so long. What a disaster. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.